3.6, and that is f of x equals natural log of x squared minus 2x. I know the problem is not asking us to find the domain of this function, but can anyone give us the condition that this has to be written and solved in order to find the domain? I'm going to start with find domain. Can anyone tell us what we have to write? Don't solve anything, just tell us we have to write this and then solve it. Anyone remembers the domain of a log function? Anyone?
Is it negative infinity?
So say it again.
I say, is it negative infinity to positive infinity?
So let's graph it. Cameron, what did you want to say?
I think it's 0 to infinity, excluding 0.
So yes, so you are talking about natural log x. I completely agree. So the graph of natural log x is this, in which the condition has to be strictly greater than 0. X has to be strictly greater than 0, so the domain is indeed 0 to infinity. There is a vertical asymptote at 0. But we do not have natural log of x. We have natural log of something else. So then what do I have to write? So good, this is a good starting point. Very good. But then what do I have to write for this? Anyone?
X squared minus 2x not equal to 0.
But this is not what we discussed, right? Did I write here x not equal 0?
No.
No. So then that's not the case. So then what do I have to write?
Greater than.
Yes, brilliant. Yes, that's what I have to write. Natural log can only be applied to positive numbers and not 0. This is quadratic inequality. So do not move this term to the other side and take square roots, or no, we have to factor. And one way of solving such an inequality is x is the variable in the problem, which can be anything. X is the first factor. X minus 2 is the next factor. And we are interested in studying the sign of the product. I need this concept for chapter 4 and also for chapter 3, section 3.7 that we are going to start right now after this. Not immediately, I have another concept. So, when is this 0? When is x 0? When x is, I know it's silly. X is, exactly. When is x minus 2 0? For what x?
2.
Of course. So I'm going to put 2 and 0 here. What is the sign of x between these two? Plug in a number and just give me the sign. I don't need the number you plugged in, just the sign. So in x, we plug in a number between negative infinity and 0, and you just give me the sign.
Negative.
Perfect. And plug in any number to the right-hand side of 0, which is it's 0. What is it? Sign.
Positive.
Oh, awesome. Which we know this. Both of them are linear functions with a positive slope. They have to come from negative numbers, they cross the x-axis somewhere, and they have to go positive. Both of them have the same slope. If I had this slope, then I would have said positive and negative, because it's coming from positive and goes to negative. But both of them have a positive slope. So then what will you say the sign here before it's 0 is? And what is the sign for this beyond it's 0? plug in a number. If you don't want to think in those terms, just plug in a number between negative infinity and 2, and just tell me the sign.
Positive for
Let-
1.
Okay, so let's try. If you want to plug in 1, 1 minus 2.
Oh, negative.
Of course. Remember what we said. It's a linear function with a positive slope. It cannot come from positive and go negative, because it would have been it would have had a negative slope. But it has a positive slope. Both of them have a positive slope. So they come from negative numbers, from negative infinity, and go to positive infinity. So this must be positive. What happens to the product when x is 0? What happens to the product when x is 2?
They're both 0.
Absolutely, because the product of 0 times something is the same with something times 0, right? 0. Awesome. When I multiply two negative numbers, negative times negative, what do I get?
Positive.
Excellent. When I multiply a positive by a negative, positive, negative.
Negative.
Excellent. When I multiply two positives, positive times positive.
Positive.
Yes. So now, only now I look here. What sign is greater than 0? Is it positive or negative? Which one? I know it's silly.
Positive.
Okay. Is this product ever positive?
Yes.
For which values of x? I feel like I'm only talking to Cameron. So then this inequality has x in what interval? Which is also the domain. When is this?
Negative infinity to 0.
Awesome. Negative infinity to 0 with a parenthesis, because we cannot have the equal symbol. Yes, union. Awesome.
2 to infinity.
That's it. Great job. This is very important. You can say, I don't want to use this table. Fine. But it will be more difficult for you to identify when to choose a close bracket or bracket and when to use a parenthesis. There are other methods. If you know one of them, that's fine. Use it. But be very careful, because those methods do not emphasize which values are included and which values are not. Careful. So the whole purpose of this problem really was to find the derivative. So let's find f prime of x. Can anyone tell us how we differentiate natural log? What is the formula?
1 over x.
1 over whatever. Good. Times
2x minus 2.
yes, brilliant. Very you said 2 and I wrote 3. So indeed, because the derivative of this function is 2x minus 2. You don't have to do anything else, unless we can simplify it a little bit. Let's see if we can. Am I still centered here? Okay. So page 2. So then f prime of x equals, I factor out a 2 and I get x minus 1. And I factor out an x and I get x minus 2. So there is nothing I can do here. This is it. Good. So allow me to continue, and we will have way more situations with natural log, I promise you, and log. Unless you found another problem that you want to work on. Did you find something else, or can we move on? Okay, so far we talked about implicit differentiation. Then we moved on to natural log and log with base a, natural log and log base a. And now we're going to look at something called logarithmic differentiation. It's a technique. It's a technique that is used in 2 different situations. Number one, that I'm going to talk about later, because this is the most important one. Okay, number 2. I will come back to number 1. Number 2. Now, when we want to differentiate x to the 3rd power, can anyone give us the answer quickly?
3x.
3x.
Very good. Now, what if I have f to the 4th power, a function, not x? What will I have?
4 f cubed times f prime.
F prime.
Brilliant. Thank you very much to all of you. Awesome. Great job. Okay. I just wanted to have a side note here. Now forget about this for a moment. Just for a moment. What do I do if I have a function raised to another function? This is not the situation. So you cannot say this. Here it's a function to a number. Here is x to a number, but this is not a number. So this is a
Would it be
function. Yes.
So
Say-
would it be similar to when we have a constant raised to a function?
No.
Okay.
No rule.
Just use the chain rule. Oh, no
Yeah.
rule.
Careful.
Oh,
Careful. So if we have a function raised to another function, and I will work on an example because it's easier to explain, and then I will come back and draw a conclusion. So I'm going to just let you choose if you want. Choose an example. So here are the examples that I'm talking about. A function to a function. A function to a function. A function raised to a function. A function raised to a function. Cosine raised to x. Sine raised to natural log. X raised to natural log raised to cosine. Choose one.
Do we
56.
do the one where it's y equals x to the x?
Yes, but that's a very
So
simple.
That's a good simple.
Yes, it's two. I promise I'm going to write it down on the side. I will not forget. I will come back to 49. Okay, in that case, allow me to choose. I'm going to choose. Which one did you choose? There was something else?
Yeah, I said 56.
56. Okay, 56. So we have y equals natural log raised to cosine x. Okay. Let me see how I'm on time. Okay, good. So this is the situation where f is a function and g is another function. These do not work anymore. This method is not applicable here. Don't cross them out like that. Everything you said is perfect. But I'm just making the point. Do not try to apply this here. It's not going to work. So what we have to do is apply log to both sides first. So apply natural log to both sides. Perfect. So I'm going to apply natural log here and natural log here. The left-hand side is natural log y. The right-hand side is natural log of natural log x raised to cosine x. Perfect. Now, how do we simplify this a little bit? We have log has 3 properties: the power rule, the product rule, and the quotient rule. So is there any way I can simplify this side? This is algebra. Do we remember those 3 rules? Do we remember those 3 rules?
No.
Okay, then I have to come back. So only log in any base has the following properties. Log A plus log B. Of course, this is dynamic. From here, here, from here, here. So this is the product rule. If we have 2 or more factors, I can have 15 factors, but in general, we work with 2. 2 factors or 3 or more, doesn't matter. Log A plus log B. We are not distributing log to this. This is not the distributive law. It's the property that says that log applied to a product is the sum of the 2 logs. We have the same thing for A over B. Same property, but with minus. log A minus log B. Again, dynamic. If we need this simplified then or expanded, then if we need this to be condensed, back and forth. And the last one is the property called power rule. The power goes in front as a factor. Again, back and forth. Okay, so C is the power of A, so C goes in front as a factor, meaning multiplied. When we say factor, it means that it's multiplied. Good. Product rule, quotient rule, power rule. Awesome. So then coming back to our expression here. Is there a way of simplifying this?
Did you bring the cosine of x down?
Excellent. Oh, cosine x, of course, yes. Natural log of natural log x. Excellent. We are using the power rule, bringing the power in front as a factor. Great job. Thank you so much. Good. So now I applied log, and now I'm going to differentiate implicitly. That's it. There is no other rule for this. There are two steps. Apply log first, and then differentiate implicitly. This is no specific rule other than two steps. If you want to say two-step rule, I would agree. Apply log first, and then differentiate implicitly. So I'm going to copy it again here because I have all these in between. So we have natural log y equals cosine x times natural log of natural log x. Perfect. So now we are going to apply differentiation to both sides. So let's do that. So let's start.